It's 2 times total, but how many for each circle?
2.
Once for this circle. Behind me. All right, we have one more thing before we get started on some examples. How many tangents are in this problem here? How many lines touch that circle exactly once? 2. Which line touches the circle exactly once? B to C is 1 tangent, and B to A is another tangent. So there's 2 tangents in this one.
Some of our papers have a whole right there where the B should be. Go ahead and just write in that B and
So if you need to put that B there, right, if your hole covered up that B, maybe put a B right in that hole. Okay. If 2 tangents meet at the same point, so in this case, our 2 tangents are AB and CB. What point do they meet at?
B.
Nope. Yep, they meet at B. They intersect at B. Then we know that those segments are congruent. So we know that AB is going to be congruent to BC or CB, yeah. Alright, you're going to get one more glue in. This time, you are going to just glue it all in vertically, kind of centered on your next page. I would glue it on the next page vertically. Don't cut it at all, just glue it in. You're going to do these 3 examples, and then you have the rest of the time to do your practice. Alright, so I would glue this in on the next page. These are your examples.
I'm going to do 3 examples. You can just leave them whole, glue them right in, and split your page as you go. Or if you want to cut them apart and space them as you go, you can do that. But you have to be really careful that you match up the right example to the what group you want.
So I'm just gluing it on this side. I have this page open. Alright, so this is on the next page. I just glued them all. We have 3 problems, so I'm just drawing my lines between those problems. Obnoxious.
Me?
Yeah, the
What did I
whistling.
do?
Whistling.
That wasn't me. That was
You
him.
just did.
That was him.
Okay, well, you just try it again.
Don't even have it. That was not even me.
Alright. About 10 more seconds and we're going to get started on this one. So get that glued in. Alright, what is our line that it appears to be tangent here? Which line does it look like it's touching that circle exactly one time? The 20, 12, or the 18? If we extended the line, it would... Audi County, guys. Holy cow. Hi. I can't put your phone away. We wanted to touch the... We wanted to touch the circle exactly one time, so it's going to be the 18, because if we extended that line, it would still only touch that exactly once. So this is that tangent line. What do we call the 12? The radius. It goes from the center of the circle to the outside of the circle. Miss, if I sit here, I'll never talk. I won't talk. Doesn't matter. Don't talk. Alright. So, because we have a radius and a tangent, we know that those two should cross at how many degrees? It should be 90 degrees. So now we have a right triangle. Here's my question is, I want to know, is it a tangent? If it's a tangent, it should be 90 degrees. Is there a theorem that has to do with right triangles? What theorem has to do with right triangles that we use quite often? Pythagorean. So we're going to do our a squared plus b squared equals c squared. And in that Pythagorean theorem, which one is the most important part? A, B, or C? C. C has to be the hypotenuse, or the longest part. So which one is the hypotenuse? Which one's across from the 90? 20. So 20 is going to go in for C. And then the other two, does it matter which one goes where? Nope. So we could do 12 squared plus 18 squared, or vice versa. If it's a right triangle, this should end up being true statement. It should end up being equal. If it's not equal, then we know that's not a 90-degree angle. So in our calculator, I'm going to just do both of these at the same time. 12 squared plus 18 squared. Oh, you can't see what I'm doing. There we go. 12 squared plus 18 squared is going to be 468. $20 squared. And see if those are equal. 20 squared is 400. Right triangle. Are they equal? No. So is it a right angle? So is it a tangent? No. To make it a tangent, it would have to make that 90-degree angle. It would have to be equal with that Pythagorean theorem. Yep, it had to be like 400 and 400, or 468 and 468. Yep. Alright, 2 more problems. For this one, we're going to assume that this is a tangent. So assume it is a tangent. Where else have we heard of that word tangent? Or where else might you hear that word tangent?
We did talk about it when we just
Oh, you did?
started.
Oh, cool.
Maybe thinking we're talking about something different.
We aren't.
We already
We
said it.
already, what did we say? Sorry, I wasn't here.
We said we talked about it when we did sine, cosine, and tangent, and that that's related to right triangles, right? That's what we said.
And we know that if we have a tangent and we create a radius in that tangent, it's going to make what? A right triangle. That's why we have tangent here, and we did it with that right triangle trigonometry. I like to also think of like if you go off on a tangent, it's like if you go off on a tangent, it's like you're kind of connected to where you're going, but you're like going off in a different direction. It's like, nah, going this way, tangent. All right, so we know we have a 90-degree angle where those two touch. Okay. Now this question mark is only for this part of the triangle. Do I know the other part of that triangle? It goes from the center to the outside. What do we call segments that go from the center to the outside? They're a radius. So if this is 12, then this is also 12. For this one, though, we're just going to call this whole thing x. And then we'll figure out that question mark at the end. Alright, so we have a squared plus b squared equals c squared. I'm going to start with that c, that hypotenuse. Which number is my hypotenuse? X. And what are my legs? 16 and 12. Now, to get x by itself, do I have to do any subtracting? Do I have to get rid of anything, or is x kind of already by itself? We'll have to take out the 2 eventually, but there's nothing else there. So we're going to write x squared equals, we just kind of flip it around. And then in our calculator, we'll do 16 squared. And this time we're adding them together because they're on the same side. And we get 400. 16 squared plus 12 squared is 400. And then like Fatu said, we have to get rid of that 2, that's squared. How do we undo a squared? Square root. So x equals 20. Is that what we were looking for? 20 is the whole length. We knew that this is 12, so how do we find that? We would do 20 minus 12, which is 8. So our answer would be 8 units. We use that word units when it's not labeled, when it doesn't say like feet or millimeters or kilometers or miles. We just say units, saying whatever we're measuring it in, that's going to be the same thing. All right, we have one more problem to do, and they have the rest of the time to work. Okay, so for this problem, this is going to be coming from this idea here, what we did in that definition. Okay, remember when they intersect at a point, those two tangents end up being the same amount, but it's when we start at that point. In this problem, my main goal is going to be to find the perimeter. And to find the perimeter, what does perimeter mean? What? Not area, but around, the amount around it, yep. So we need to figure out all these outside amounts. Okay, I'm going to start with this one. I'm going to color code a little bit. That's a tangent. It meets at this tangent on the top. What other tangent is going to be congruent to that? Is it the 11, this one, the 8.7, or the one right next to it? The one kind of next to it that shares that corner. These are congruent to each other. And then I have that 8.7. That's going to be different. It goes to this corner now. But coming from that same corner, we have this part here. So those two are congruent. And then lastly, we have this corner, which is congruent to that other one. So what can be a little confusing about this is that when we look at congruent parts, we're looking at those parts broken up. We're not looking at the whole 17.7. All right. What do you guys want to start with, the blue, pink, or orange? The blue? Okay. So if this is 11, what's this? 11. Nice job. What other part do we know? You guys want to do pink or orange? Yeah, the orange is going to be on the other side. 8.7 and 8.7. So how much is the whole length across on this side? $19.7. We would add them together. Now, last part I need to find is the pink. So if I know that the whole thing is 17.7 and this is 8.7, how can I find the other part?
19.7 minus
Close. We're going to take the 17.7 to start with, the total. We're going to take away the part we know. 8.7. Yep, subtract. Okay, which is 9. Perfect. So we know that that pink part is 9. Which means that the other pink part is 9. So how much is this whole side now? $20. Yep, 11 and 9 is 20. So to find the perimeter, we want to add up all the sides. So we're going to do 20 plus, what's another side? 17.7 plus 19.7. We just add up all three sides of the big triangle. And I would use a calculator to do that personally. 20 plus 17.7 plus 19.7, 57.4. It didn't tell us what we were measuring in, so since we didn't know what we were measuring it in, what should we label it? Units. And that is it for your notes. So I would keep your notes out because your practice literally does like 2 of the first kind, 2 of the middle, 2 of the last. Okay, so keeping your notes out is going to be really helpful.